Welcome to section 5.3, special factoring methods. Alright, so we have a few different methods we're going to look at, and the first one is, I'd say very common in this course, would be something called the difference of squares. Well, the main thing to look at, the difference, we should think of subtraction. And then squares, well, we're thinking of items that are being squared, right? So for example, x squared minus y squared. This would be called a difference of squares, because there's a difference and both of the items are squares. Now, the special method for factoring this is x minus y, x plus y. So notice, it's the item before it was squared, and we have a plus and then a minus. So two different things, a plus and a minus. And these items here on this side, these two binomials are called conjugates. Conjugates of one another, because they have the same first terms and same last terms, but different signs. Okay, so let's take a look at actually factoring. So real quick, there is a typo. Go ahead, cross this one out. It should be 2x squared minus 8y to the 8th power. Alright, so first we're going to check for a greatest common factor. And since both of these two terms are even, we can go ahead and pull out a 2. So we have x squared minus y to the 8th. Oops, sorry, that should be a minus 4y to the 8th. After that, so notice we have a subtraction sign. This could possibly be a difference of squares if we can rewrite the first term and the second term as squares. Let's see, we have 2, and I'm going to go ahead and do this on the side. X squared is technically x squared, right? And then the 4, y to the 8th, can we write that as something squared? Yes, we can. We can write that as 2y to the 4th power, right? Because if we distributed the 2 to each of them, we would get 2 squared y to the 8th power. Okay, so we can rewrite each term as something squared. So we have x squared minus 2y to the 4th squared. And I'm going to go ahead and show this work on the side. You wouldn't usually need to show this, but because we're working on a new problem, I'll write a little more work. So we have x squared minus 2y to the 4th squared. Now, how does the rule work for factoring? Well, we take the unsquared version of each one and place them in the binomial. So let's go ahead and do that. So we have x, and then we're going to take the last one, 2y to the 4th, 2y to the 4th, and then put 1 plus and 1 minus. And we're done. Once again, note we input the unsquared item into the binomials. Alright, so let's go ahead and write that down. That was just the side scratch work. So we still have that 2 following along, and then we said x minus 2y to the 4th, and then x plus 2y to the 4th. Now, whenever I see a minus sign in a binomial, I might think it's a difference of squares. So I see that minus, however, this is not a square. That x is not a square, so we're done. Everything is factored. Let's take a look at the next one. Well, I see a minus sign, so this could possibly be a difference of squares. The question is, I have to figure out whether this first item is something squared and whether the last one is. Well, the last one, that's easy. That's just 1 squared, right? 1 squared is 1. Okay. But the first one, can I write this as something squared? I have to be creative here. 79 is 7 squared, and x plus 2 squared is just x plus 2 squared. So I can rewrite this as 7x plus 2 squared. Okay, so I'm going to go ahead and rewrite everything. So we figured out what these squares are of each item, or you could think of it as a square root. So I know that this is 7x plus 2, sorry for my dog barking in the back, squared minus 1 squared. So now we know the first item being squared and the second item being squared. So we can rewrite it as x and the x value, and then the y, the y and the y value. Let's go ahead and do that. So the first term is that huge x plus 2, and then we'll go ahead and do the minus and our last term. So that's the first binomial, the minus, and then we'll do the next one. 7x plus 2 And then finally we have the plus 1. But we have to simplify these two. Because we have that 7 in the parentheses, let's go ahead and distribute the 7. And we'll get 7x plus 14 minus 1 times 7x plus 14 plus 1. And then, let's see, simplifying, so let's go ahead and add the like terms. And what do we have? We have 7x plus 13 and 7x plus 15. And we're done. We have our two multiplication problems perfectly factored. So now, the next thing we have is the sum of squares. A little different, but a similar idea. We have a sum, which would be addition, right? And then of two items being squared. Now this one, in Math 103 or below, so any course below or Math 103, would be considered prime. We don't factor these. So, whenever you see something that's a sum of squares, you would say it's prime. It's not able to be factored. Alright, so you could go into that and you could try find a way to get that, but there is no way to get that with the numbers that we use in the classes below 103. So let's see the first one. A, we have a plus sign, and are each of the items squares? Well, that's a perfect square, x squared, and then we also know that 1 is a perfect square. So this is a sum of squares, which we know is prime. I don't have to worry trying to factor it. I already know it's prime. It's a sum of squares. Now let's take a look at the next one. B. Well, this one's a little weird. It's not a sum right now. There's still a minus sign there. But notice, I could actually factor out something from each of these. They both have a 5 in them. So let's go ahead and factor out that common factor of negative 5. And then I'm left with m squared plus 4. Ooh, and what do you know? This is a perfect square, and so is this. Oh, however, that's a plus sign. So we know that that, right there, that binomial, this is a sum of squares. So you might be tempted to say, well, then our answer must be prime, right? However, you have to be careful. We did actually manage to factor the original expression, right? We factored out the 5. So we wouldn't write prime for this. Even though there is a sum of squares, we still managed to factor the original one. Alrighty, so that would be our answer. Let's go ahead and box that. Alright, moving on. So factoring perfect square trinomials. What are perfect square trinomials? Well, basically, if we have something, so this is the generic form. Once again, you can read these in your book, in the section, when you're reading the section for this week's. So if you have x squared plus 2xy plus y squared, it factors perfectly into the exact same binomials. Notice these two are not conjugates. They have the same sign on the inside. And then we can rewrite this as x minus y squared. So that's the positive version. I didn't exactly leave a whole ton of room for this, so let me go ahead and move it over here, and then I'll rewrite the other one above it in a different color. Did not use room that wisely. Actually, let me go ahead. Okay. So that was the plus version, and then we also have the negative version. If we have x squared minus 2xy plus y squared, we can factor that perfectly into the exact two terms x minus y, which we can rewrite as x minus y squared. Now, how can we identify these? That's the main thing. Well, if you'll notice, on both of them, if we have one term on the beginning and then the one term in the end, the middle term is that first term times the last term and then multiplied by 2. And that happens for the other one. Now, this is just a pattern that some mathematician noticed with certain trinomials and decided to call it the perfect square trinomials. Okay, I usually don't often have this happen when I'm factoring, but it's just a special method. So let's take a look at example 3. Factor p squared minus 8p plus 64. There is a small typo in this, and hopefully I fixed the typos that are appearing on this before you guys get the notes. So this is p squared minus 16p plus 64. Alright, how would I know if this is a perfect square trinomial or not? Well, the main things we look for are, 1, that the first item is a perfect square and that the last term is also a perfect square. Well, the first one, the first term, it's easy to tell that that's a perfect square because that's already p squared, right? But the last one is a little harder. Is 64 something squared? It is. It's 8 squared, right? So I can go ahead and rewrite this as p squared minus 16p plus 8 squared. So that was the first test, to make sure the first term and the second term were perfect squares. The next thing to see is the middle term 2 times the first term times the last term. And not the actual squares in the terms, the square roots of the terms. So let's see, is it the same? Well, we have 16p. It is. Alright, so we proved that it is a perfect square trinomial. Alright, so let's go ahead, and that means we can rewrite this as the first term, which we found out was p, and then the second term, which we found out was 8. So we can rewrite it as p, oh, and careful, we're working with the negative version. So it means we had two negatives. So it's going to be p minus the second term, which is 8, and then p minus the second term. We go ahead, that should be a minus sign. And then minus the second term as well. They are going to be identical. Okay, so it's different than the difference of squares. These guys end up factoring as identical binomials. So since they factor as identical binomials, we can rewrite it as p minus 8 squared, because there were two of them. 1, 2 gives me that squared. Alright, and to check our answer, we could go ahead and FOIL. You don't need to check your answer, but if you want to, always remember you can FOIL. First, outside, inside, and last. And that does indeed give us the p squared minus 16p plus 64. Awesome. Alright, so once again, this one doesn't show up that often, but if you want to go ahead and memorize the formula for it, you can. Okay, so moving on to some of the next methods for factoring. We have factoring the difference of cubes. Okay, so now this is interesting. So recall, we have the difference of squares, which looks like this. Let me go ahead and write it down. X squared minus y squared. Remember, we factored that into x minus y, x plus y. And then we have the sum of squares, which is x squared plus y squared, and that is prime. So now we have something called the difference of cubes. Very similar concept. We have x cubed minus y cubed. Now this is factorable, and it factors into a binomial and a trinomial. So we'll get x minus y, and then we have x squared plus xy plus y squared. So if you notice, the only time the minus sign follows through is in that small little binomial. In the trinomial, we have plus signs. So, small typo, hopefully I have fixed it on your notes. It should be an x cubed minus 8, as we are looking at the difference of cubes. Alright, so we have a binomial, once again, two terms, right? 1, 2. Then we have a minus sign. So there are two things this could be. This could be a difference of squares, x squared minus y squared, or this could be a difference of cubes, x squared minus y cubed. How do we know? Well, let's look at each of the factors. This has a cube, which means it's more than likely not the difference of squares. And then 8, is that a perfect square or a perfect cube? That's a perfect cube. So I can rewrite this as x cubed minus 2 cubed, because 2 cubed is 8. 2 cubed is equal to 2 times 2 times 2, which is 8. Okay, so then that helps me identify what my x and my y values are. So my x value, in this case, is still an x, and my y value is actually going to be a 2, which means I'll rewrite it as x minus 2 in the beginning, so the first term, x minus 2, and then we have the trinomial coming up. And I'll rewrite it as my x value squared plus my x, oops, sorry, wrong color, should be x is blue, and then my y value times my x, and then finally the y squared. Ooh, tripping over my words there. All right, so my x value is still the x, so we have x squared. Then we're going to do plus x times y. So my x is still an x, and then my y, though, remember, is a 2 in this case. And lastly, plus my y squared. Oops, almost ran out of room there. Let me just erase that and make more room. So that's supposed to be my last value squared, which will be 2 squared. And then let's go ahead and simplify this. We have the x minus 2. X squared we can just rewrite without the parentheses. Plus, multiply that out, 2x. And lastly, we have 2 squared, which is 4. And we are done. Now you might ask, do I need to check if this trinomial needs to be factored? The answer is, if you took out the greatest common factor in the beginning, this trinomial should be prime. That's if you made sure to check this for factoring before. Okay, let's take a look at the next example. So we have negative m to the 4th plus 9my cubed k to the 6th. I just know this is a binomial, but off the bat, I really wouldn't say this looks like a difference of cube. But as usual, always remember to take out the greatest common factor in the beginning whenever you're factoring, before you do any of the special factoring methods. So let's see what we can take out. Well, they both share an m. But other than that, they don't really have anything else in common. So let's go ahead and I'll factor out a negative m. And then I have m cubed minus 9y cubed k to the 6th. Okay, so I'm going to ask myself, I have a binomial, so 2 terms, and it has a minus sign. Once again, my brain's going to think it's either x squared minus y squared, or x cubed minus y cubed. And if it's neither of these perfect forms, it's prime. Well, I know it's not going to be the difference of squares because I have that cube on top of the m. So it's possibly a difference of cubes. How do we know? Well, we have to check. The question I'm going to ask myself is, can I rewrite the first term and the second term as something cubed? Let's see if I can rewrite these as something cubed. So m, well, I can just rewrite that as m cubed. Now this one's a little trickier. Can I rewrite that as something cubed? The answer is yes. 27 is 3 cubed. Y to the 3rd power is y. And then k to the 6th, we could rewrite that as k. Let's see, what times 3 would give me 6? 2. K to the 2nd power. Once again, we're using the power rule here. If we multiplied that out, you would get 3 cubed, y cubed, k to the 2 times 3, which is 6. Which would once again be 27, y cubed, k to the 6th. So we rewrote it correctly. Alright, let me go ahead and erase this so we can set it up a little better. But I'm still going to write it with the items in their cubed form. Let's go ahead, we still have that negative m. So we have m to the 3rd power minus 9yk squared to the 3rd power. And now we have found our x and our y values. So my x value is m, and my y value is 9yk squared. Kind of big, but it's still technically our so-called y value. So let's go ahead and plug these items in. So for my binomial, I have my x value, which in this case is m, minus my y value, which in this case is 9yk squared. And then we multiply to that my x value, which is m squared, recall up there, plus my x times my y value, so that'll be my m times 9yk cubed, squeezing this in barely, and then lastly plus my y value squared, so 9yk squared, squared, fit it in, awesome. Well, we plugged everything into the formula, so all we have to do now is just simplify things, get rid of parentheses, and multiply things out. Alright, so now we have m minus 9yk squared. Then I'll simplify that to m squared plus, and then multiplying these guys out, I'll get 9myk cubed plus, distributing that square to all of the terms, I'll get 81 y squared k to the 4th power. Once again, the trinomial, if we made sure that we factored it in the beginning, the trinomial should be prime. So no need to worry about trying to factor that. And we're done. Okay, so that was the difference of cubes. Now, we'll take a look at something similar, but this one is the sum of cubes. Alright, so what is the sum of cubes? Very, very similar. We have x cubed plus y cubed. Now this time, instead of it being prime, like we had for the sum of squares, which remember is this, which is prime, instead it actually factors. The difference of cubes factors into x plus y, then x squared, and this is where it's different, minus xy plus y squared. You'll notice it factors in almost the exact same way that the difference of squares factors. The only difference between the two is these signs right here, this one and this one. The first sign copies the original, and then the second one is the exact opposite. Same thing here. First one copies, the second one is the exact opposite of the original sign. Let's go ahead and apply these. So I'm going to use pretty much very similar looking binomials for the first one. So I'm just going to go ahead and rewrite this. So I have a binomial and I'm trying to factor it, and it has a plus sign, which means it's either the sum of cubes or the sum of squares. And we know this one is prime. Well, since the first value is a cube, we know it must not be the sum of cubes, which means it could possibly be the difference of, or the sum of cubes. So it's not the sum of squares. We have one option, and if it's not this one, then it's prime. Alright, so let's see, can I rewrite it as 2 items cubed? And the answer is I can. This is x cubed plus, and 1 is awesome because 1 can be written as anything to any power, 1 cubed. Alright, so following the formula, this is my x and that's my y, so we have x, 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 and then y, 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 y. That sounds like a sad song, y, 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 y. Okay, let's plug them in. So the first one we use is x plus y, so x plus, this time we're replacing the y with the 1, and then we have our x squared minus our x times y, which is actually going to be x times 1, plus the 1 squared. Now we can simplify that, x plus 1, x squared minus x plus 1. Once again, can we factor the trinomial? The answer is, if you checked that there was no GCF in the beginning, then it is prime. And we're done. Now let's check the last one. Ooh, this one looks kind of interesting. It's a binomial. But as usual, we always check to make sure that there's no GCF, or if there is a GCF, we factor it out. Now both of these, real quick, sorry, that should be a 40, not a 45. Both of those have a 5 that can be taken out of it. So we'll go ahead and let's take out that negative 5. And we can also take out the m. Other than that, there is nothing else in common. So we're left with m cubed. Ooh, careful, we factored out a negative, so it's going to be a plus. And then 5 and 40, that's 8y cubed k to the 6. Okay, so we took out our greatest common factor, and we're left with this binomial. So either we're done, and this is prime, and we don't need to keep factoring, or we can factor this binomial. Now it has a plus sign, so once again there are 2 options. Sum of cubes or sum of squares. It's not the sum of squares because we have that cube going on right there, so the option is it could be a sum of cubes. How do we know? Well, we have to check, right? So can I rewrite each of the terms as something cubed? If I can, then I know it's a sum of cubes. So go ahead, try pause the video, see if you can figure out how to rewrite them. Well, the first one is m cubed. That's pretty easy. The second one, how would we write that as something cubed? Well, 8 is the same as 2 to the 3rd power, so I'll rewrite 2. Y would just be y, because it already has the 3rd power. Lastly, k is a little trickier. What do we multiply 3 by to get a 6? And that is, once again, 2. Alright, so we have figured out our x and our y values. Alright, so let's go ahead and factor this out. We have negative 5m, and then for our binomial, x plus y. So in this case, this is my x and this is my y. So I have m plus my y value, 2yk squared. And then my trinomial, and I'll try really hard to squish this in. So my x squared is m squared, minus my x value, which is m, and my y value, which is this one again, 2yk squared. Lastly, plus my y value squared, so that's 2yk squared squared. And my closing parenthesis. Whew! A lot of work. And lastly, let's go ahead and simplify. Minus 5m, m 2yk squared. M squared, we'll simplify that and drop the parentheses. Minus, we'll go ahead, multiply that out. The order doesn't super matter because, yeah, just alphabetically if possible. And then lastly, we'll go ahead and distribute that 2 to all of the values. And we have 4y squared k to the 4th. Is everything simplified as possible? Yes, if you factored it in the beginning to take out any greatest common factors, it is. Alrighty, and that is it for this section. So the two really new ones for this course are factoring the difference of cubes and the sum of cubes. So I'll say this as a word of warning. Know how to do these because it's highly likely they will show up on an exam. Alrighty, once again, if you need help with any of these problems, please come by my office hour or send me an email and we can set up a time to meet and discuss them.